From transformative drones to complex geometries, the wheel has been redefined by robotics. The M4 set the bar for what a hybrid vehicle can do. It has actuated wheels with integrated propellers. This allows it to travel on the ground in order to save energy. In other words, it can bypass the limited flight time and have a longer range when compared to a typical drone. Another really impressive craft out there which has this transformative ability is the Dragon drone. This was a multi-hinged platform that can transform into different things to get through obstacles or produce more front-end torque for turning valves. The downside is that it can only fly for around 5 minutes. It's very energy intensive. The release of the Delta robot was very interesting because it kind of combined the attributes of the M4 and the Dragon. With linked modules and vectorable thrusters, it can transform into the wheel itself. Yet, it can form different kinds of objects when it's flying in the air. It would be able to save energy, but at the same time transverse to a different location on the ground at a moderate speed. Once it reaches its final location, it can transform in the air to perform a specific task just like the Dragon drone. It is still a prototype, so arguably it needs some tweaking for faster servo response, but it does demonstrate the potential of multi-linked robots. However, the Monocycle hybrid robotic platform is very complicated and tricky to balance. So how can we even make this more advanced in the future? Well, one possible way is to incorporate actuated components. And the Ringbot does just that, with independent driving modules which fit inside the body. Each module can track its orientation or even make full rotations inside the wheel. This allows it to drive up to 3 miles per hour, yet it can displace its weight and actually turn to make it usable. In order to verify the concept of this particular robot, the controllers were tested in a simulation environment, and this was later implemented into the real world. The team plans to build even a more sophisticated variant in the future, and it might even be possible to incorporate this into a hybrid robotic flying drone, so robots can transform into wheels. But how the wheel is purposed in the platform is a different kind of matter. The Animal is arguably one of the more impressive robotic dog variants. It is based on reinforcement learning with a reward-based setting. So it can learn these motion controls in a trained environment, or in other words, a simulation, and then it understands both manipulation and locomotion. This can be later implemented into the actual robot with high amounts of success. It definitely surpasses what a typical robotic dog can do, but it utilizes the wheel for manipulation of objects, and that is what is so unique about this particular robotic platform. The wheel can even be modified further into different complexities, but this is the tricky part, because you want to maintain a smooth, round surface for efficiency, yet you would want something that can climb over objects, so it has to be transformative in some sort of way. The Omni-Wag is a bit of a step up from the Animal in terms of maneuverability, because it can transform its smooth wheels into a wheel leg for climbing obstacles. But it also has a mechanism drive on each wheel, which means that there are rollers placed at 45-degree angles. By spinning the wheels in certain patterns, you can utilize the diagonal force exerted by the wheels to move the robot in any direction. Each wheel would need its own drive to deliver this pattern driving, but it also needs a servo to engage this wheel leg. The PATS wheel takes a different approach because it uses one mono-transformable part that has a pad, claw, and coupler. In rough terrain, the pad gets pressed down, and this allows the robot to climb objects. But what makes this particular robot very unique is that it's based on one single printed component with no extra sensors, actuators, or controllers for that matter. In some ways, it's like a metamaterial where the structure moves in a predetermined way. And it's an ingenious design because the wheel is highly reactive, but it can maintain its efficiency. Now, we have seen many of these robots before, such as the Cube, but the Wheelbot is an interesting prototype because it can measure rotational velocity and acceleration. It accelerates an extra reaction wheel, and in turn, this allows it to drive on the single wheel on the ground. But it also can stand up from a standstill using a reaction control event. To summarize all of this, what we're looking at is how reinforcement learning is advancing robotics through training and simulation. Now, the Dragon drone was a preliminary vision of what is possible in drone technology, but the Rainbot could shed some answers about how to make this even more maneuverable as a monowheel design, and maybe we will see something very advanced in the future. The robotic dog is also very fascinating because we're seeing how the wheel can even be used as an actual hand. But maybe something like the mechanism drive will be incorporated into this round wheel design for the robotic dog, and it'll even be more maneuverable. But in the future, metamaterials are going to do a lot of different practices, especially in the electromagnetic spectrum. But more importantly, I would like to know what you think about all this, so please leave a comment, like the video if you enjoyed it, and also make sure to subscribe to my channel. Okay, see you in the next one.